Hello, today we're going to be talking about question number 5 on the 2025 AB Calculus AP test. This is only an AB question and it deals with implicit differentiation. Alright, so let's get this problem started. Okay, so let's look at this problem now. It is question number 6 and it deals with a curve given by the equation 6xy plus 2 plus y to the third. And we have to do some implicit differentiation, we have to do a lot of different things, horizontal, vertical, tangent lines, and then we deal with some related rates. So let's get this party started with part A. So our goal is to show that the derivative dy over dx is equal to 2y over y squared minus 2x. So let's take the derivative of our curve. So I'm going to start off by just writing down our curve, 6y plus 2 plus y, not 2 plus 2, is equals 2 plus y to the third. All right, so I have that 6x times y. That is some product rule business. My first function is going to be the 6x. My second function is going to be the y. So I take the derivative of the 6x. That would be 6. Keep the y the way it is, and I'm then going to add it to 6x, the normal first function, times the derivative of y with respect to x. That's all equal to the derivative of 2, which is 0. So I'm not going to write anything. And then the derivative of y to the third, that is going to be 3y squared. Dy over dx. Almost forgot that. Whenever we take the derivative of y, we need to include dx because we're taking the derivative with respect to x here. All right, so what I'm going to do is I'm going to move all my dy dx's over to the right. And I'm going to keep that 6y on this left-hand side. I'm going to be subtracting that 6x dy over dx over to the left. So then we are left with 6y is equal to 3y squared minus 6x, 3y squared dy dx minus 6x dy dx. Okay, now I can take the GCF of the dy dx out on the right hand side. So dy dx times 3y squared minus 6x, and that is all equal to that 6y. Let's divide both sides by the 3y squared minus 6x because I want to get rid of that and leave dy dx on that right hand side. So our dy dx in this case, after the division, is going to be equal to 6y over 3y squared minus 6x. Let's do some simplifying. Every single term can be divisible by 3. So then we get dy over dx is equal to 2y over y squared minus 2x. Is that what I'm given? 2y minus y squared over 2x? Yes, it is. So I am completed. Just like that, we showed that our dy dx is that. Simple as that. All right, let's go to part B. So part B, find the coordinates of the point on the curve at which the tangent line to the curve is horizontal. Okay, first off, let's write this derivative. So dy over dx, that is equal to 2y over y squared minus 2x, I believe. Let's double check that. Yep. Okay, so our goal is to figure out what coordinates do we have a horizontal and tangent line. So guess what? I'm going to figure out when is my derivative, aka the slope, have a slope of 0, because when we have a horizontal and tangent line, that's a flat line, slope is 0. So I'm going to set my numerator equal to 0. So here in that case, my numerator is 2y, so I'm going to set 2y equal to 0. I then divide by 2 to both sides. I get y is equal to 0. Now, this situation needs to be true on our curve. Our curve is that 6xy is equal to 2 plus y to the 3. So guess what? I need to show that when y is equal to 0, aka when we have a horizontal and tangent line, what coordinate does that correlate to on our curve? So I'm going to plug that y is equal to 0 into our curve. So every time I see a y, I'm going to plug in 0. So then we get 6x times 0, then is equal to 2 plus 0 to the third. we get 0. 6x times 0, 0 is equal to 2. Is that true? Wait, is that true? 0 is equal to 2? This is false. So let's think about this in retrospect. We assumed that we have a horizontal tangent line, aka we assumed that our numerator is equal to 0, meaning we had a horizontal tangent line. With that assumption, that led to something that's not true. That is a fallacy. Guess what? What we assumed was false. So our reasoning would be, since when we assumed we had a horizontal tangent line, we got 0 is equal to 2, which is false. Thus, our assumption that there's a horizontal that there is a horizontal tangent line is false. Beautiful. Let's go to part C. Part C is very similar. So part C is find the coordinates of the points on the curve which the tangent line to the curve is vertical. Okay, so vertical tangent line. What's a slope? That is an undefined slope. It's a vertical tangent line. Guess what? How do I have a vertical derivative of our dy over dx is undefined? I know that it is some number divided by 0. So guess what? I need to set my denominator of our derivative, which was 2y over y squared. Let me write that up top here. I need to set my denominator equal to 0. So I'm going to set that y squared minus 2x is equal to 0. I'm going to get some relationship here. Some relationship between our y and x's. So I'm going to add that 2 over. So we get y squared is equal to 2x. And I'm going to figure out, hey, what's a relationship where I can plug one variable in? I don't want to really deal with square roots. So I am going to get the x by itself, because if I get the y by itself, I have to deal with square roots. I don't really feel like doing that right now, so I'm going to do the other way. So I'm going to divide both sides by 2, and so we are going to get x is equal to y squared over 2. Now, using this relationship right here, I'm then going to plug that back into the original curve. So every single time I see an x, instead of putting x, I'm going to put that y squared is over 2. So we have 6. In this case, 6 times x, so I'm going to put that y squared over 2 times y is equal to 2 plus y to the third. Now let's do some algebra here. 6 times y squared over 2, that will be 3y squared, and that's multiplied by another y, so that would be really be 3y to the third is equal to 2 plus y to the third. Subtract that y to the third to both sides. We then get 2y to the third is equal to 2. Divide by 2. And we get y to the third is equal to 1. Almost there. We're trying to solve for a coordinate, so we need y. We're going to cube root both sides. Cube root of 1 is just 1, so we get y is equal to 1. All right, we're not done yet. We have to figure out the coordinates, so we need to figure out the x coordinates. I'm now going to use our relationship that we established earlier, that x is equal to y squared, to figure out my coordinate. Instead of y, I know what y is in this case. Y is 1. So I'm going to say, hey, x is equal to 1 squared over 2, which is equal to 1/2. Just like that, we have x, we have y. Our only coordinate in this case would be 1/2, comma 1 is where our curve has a vertical tangent line. All right, one more question. Our last question. A particle is moving along the curve. At an instant, right there, that should tell you something. We're dealing with time. When the particle is at the point 1, 1/2, comma, -2, its horizontal position is increasing at a rate of dx over dt is equal to 2/3 units per second. What is the value of dy over dt? The rate of change of the particle's vertical position at that instant. All right, so this is a big sign that's saying, hey, we're looking at time at an instant. We are talking about relative rates. We need to take the derivative of our original equation in terms of time. So I'm going to write down my original equation. Earlier, we took the derivative of this with respect to x. So whenever I did dx over dx, I didn't really have to notate that. But now we want to take the derivative with respect to time. So guess what? Every time I'm taking a derivative of a variable here, I'm going to need to include dx over dt or dy over dt. So let's do the product rule again. So we have our first function's 6x, our second function's y. So the derivative of 6x, that would be 6. And I need to include dx over dt because I'm taking the derivative with respect to time. So that will be dx over dt times y plus 6x, our original function on the left, times dy over dt is equal to the derivative of 2, that is 0. Then the derivative of y to the third, that'll be 3y squared dy over dt. All right, so let's figure out what everything that we have is. We are talking about the point specifically 1/2 comma -2. So I know right there that my x is going to be 1/2, and I know my y is -2. I have a dx over dt in this equation, and we know that is increasing at a rate of 2 over 3. So it's going to be positive 2/3, and I'm trying to find dy over dt. So I'm trying to find that. That is my question mark. Okay, so we have 6 dx over dt, which is 2/3, and then times y, which is -2, plus 6 times our x, which is 1/2, times dy over dt, which is our unknown, and then 3 times -2 squared times dy over dt. Let's clean up some of these numbers. Okay, so 6 times 2/3, that is going to be 4. And then 4 times -2, that is going to be -8. Plus 6 times 1/2, that is going to be 3. And I'm going to keep that dy over dt with it. And then 3 times -2 squared, -2 squared is 4. 3 times 4, that is a 12. Let's subtract that, get all the dy dt's to one side. Let's move it to the right. So that would be -3 dy over dt. So then we get -8 is equal to 9 dy over dt. We're trying to find dy over dt, so we're going to divide both sides by 9. Therefore, we have -8 over 9 is equal to dy over dt. And that is what we are trying to find. All right, and just like that, we just answered those 4 parts to this question number 6. Let's now talk about how the AP graders graded this FRQ. So if we look at this first problem, we were trying to figure out, hey, show that dy dx was equal to 2y over y squared minus 2x. So they gave you 1 point if you correctly did the implicit differentiation. So if you were able to do the product rule and were able to do the power rule and use dy over dt dy over dx when you needed to, that was worth a point to AP this year. Then you also got a point when you fully verified that your derivative was correct. And those were 2 points there. Let's go to B. So B, you got 1 point if you knew to set your numerator equal to 0. So if you knew that, hey, we're looking for a horizontal, we had to set our numerator equal to 0, you've received a point. You also got 1 point for your complete answer saying that there's no possible points. That gives us a horizontal tangent line. And you had to have reason for that. Part C, you got 1 point for setting your denominator equal to 0. You got 1 point for plugging in your expression for x into the original curve. And then you got 1 point for your coordinates. That 1/2 comma 1. So that question was worth 3 points. And lastly, this question number letter D. You got 1 point if you correctly did the implicit differentiation with respect to time, and you got 1 point for your answer. And that's how these graders graded these FRQ. And we just finished the question number 6 on the 2023 Calculus AB FRQ. It was a pretty simple question dealing with implicit differentiation. So I hope you found this video helpful, and I hope you're finding all of my videos helpful. If you do, please like and comment down below. Thank you very much for watching, and happy studying.